Okay, we should be recording now. Okay, so I got a couple of things to talk about. First thing is that hosted online on my PNW Life, if you go to files, same place where the YouTube videos are posted in the workshops file. I also have this book. Um, this was a very useful book for my senior design and for learning how to use KiCad in general. It has a lot of useful information in here. If you guys want to go ahead and learn extra stuff, there's some really useful tools in here, or even walkthroughs that will literally walk you through some other designs. Some other useful things is understanding these workflows. It tells you the workflow for the schematic design and for the layout design here. So in the schematic design, you have the setup, which is just putting your name, what company is it, what revision is it, so on. You can also set up some DRC rules there, I believe, too. You have your symbols, which are your actual schematic parts. You arrange everything, you make the connections you need. It's called associating symbols when you I can't remember if we went over that, but I already had it. But for any of you who didn't do it yet, these um, letters here, letters and numbers here, um, these represent, it's basically KiCad's way of keeping track of what components are what and transferring it over to the layout, which will be the actual PCB. So these will, when you place them, will be like S question mark, R question mark, R question mark, C question mark. Before we move on, you always have to click on this fill in schematic symbol reference designators, and you would click annotate. And if there's any issues, it'll show you errors or warnings. I have none. So after you click that, it will automatically fill in all these. So this is switch 1, this is resistor 1, this is resistor 2, capacitor 1, battery 1, and so on. So you always have to do that before you move on to the layout, or else KiCad will have no idea what components are what. It's right here. It has like the R question mark R42. Then the next thing you should try and do often is there's this electrical rules check, or ERC for short. If you click on that and run ERC, it can tell you of any problems you have. It's like here, for example, I have a warning right here that I modified symbol 7555. And then it also has a warning here that there's no pin connected here. So that can be a problem when you move into the layout. So the easy way to fix this is on the right here is add a no connection flag, and then you would just click on that side. There's no connection there because that's effectively just going to be our off and turning the circuit off. Then the other problem, I believe, was here. So it said that open back up to ERC. You can see that one problem disappeared, the unconnected terminal here. And then the other one is just that I modified the symbol. This is one of the cases where you can ignore this ERC, okay? It's just letting me know that this symbol 7555, which I personally created, I had gone into it through the schematic. I had opened it up and went to edit symbol, and I made changes. I made changes to the actual symbol that's stored in the library. So it's letting me know, like, hey, this isn't the default symbol that was created and put in this library. You made changes in this schematic. And so that's a really useful feature, I think. If you ever make changes to any of your symbols, which is completely okay, you just need to make sure that you made the correct changes. Another often change that I have to do all the time is usually changing like what pins are inputs or outputs. As you collect more symbols from online on the internet, sometimes it transfers in a weird way, or whoever made the design was like lazy or maybe didn't know as much as about KiCad pin inputs and outputs. For the most part, it's not important. They are just for the software to give you warnings like, hey, you have an output to an output. That doesn't make any sense. It should be input, output. Um, Another common thing is in KiCad, I believe for any power supply connections or any ground connections, they should both be power input. So this VDD should actually be power input. But for the most part, this is just for visuals to help the software give you warnings or to help the user understand what this symbol is. What is a 555 timer in this case? Okay, if I wanted to keep that, I would click Save Changes, and then KiCad will now know that VDD here is a power input pin, and that because of that change is the reason my error input is saying, hey, you modified the created symbol. I'm now getting another error because I changed it to a power pin, but I can ignore this error as well because I know that this is the proper connection for this specific 555 timer, the 7555. To make the arrows go away, you just click on delete markers and it'll remove all the. Okay. One more thing that you have to do is on all the components, you need to make sure that here in the footprint area that you have assigned a footprint to that device. Sometimes, depending on the library you pull it from, it'll automatically already have a footprint, and sometimes you will have to manually put that footprint in. If you can't find a footprint that fits that component, you'll have to either download one or create a footprint. All of these devices should already have footprints on the that are by default in the KiCad library. Instead of clicking on every single component and looking and seeing like, okay, this one has a footprint, there's an easier way to modify all your symbols in bulk. If you go to the top here, there's it kind of looks like an Excel spreadsheet. It'll say bulk edit fields of all symbols in schematic, and click that, and it'll show all of your components by reference, which ones which, and you can then select what footprints. So for example, this battery one, because we downloaded the DigiKey library, it should be located in the DigiKey footprints here. Do you all see DigiKey footprints? Okay. Um, so you don't see that in the libraries? Or do you see it? DigiKey library right here, or DigiKey footprints? I might have not have gone over it, so I don't remember. No? Okay. Then really quickly, um, if you click on preferences, go to manage symbol libraries. Then if you scroll, it would probably be all the way at the bottom. So I have a couple, but here's all DK is DigiKey, so here's all my DigiKey footprint. Or oh, no, no, I'm sorry, these are libraries. You will have to go. Oh no, I think those should have the footprints as well. When you guys go to manage symbol libraries, do you guys have all of these? No? Okay. Okay, if you go back and you watch the first video, I have it on YouTube, IEEE PNW. You can watch how I got the library. Yeah, it should be in there as well. It should be in the workshops folder. If not, then I'll do that right after this session. Um, Okay, so you have those libraries, but you said that in the footprints that you didn't see anything. I didn't mean to click that. All right, we'll have to fix that. Okay. Um, Give me 1 second. Okay, so I want you guys to click on this right here. Create, delete, and edit footprints. So this is an area where it tells you exactly what you would do, but you can come here to view different footprints. So these are for audio modules. There's some battery footprints here that should be by default in the KiCad library. We want the DigiKey footprints. So I want you to click on File and Add Library. And then you have to select whether you want it as global or project. That's to your preference. If you put it in global, then any of your other designs will see that footprint. If you put it in project, then only this specific project will see that footprint. So sometimes it can help you organize things. I'm going to put in global. And then you're going to want to go to wherever you saved the DigiKey library. From the last episode, we got this DigiKey KiCad library master. If you go here and then go to footprints.pretty, you actually don't need to open this up and select anything. It just needs the folder. And KiCad uses this .pretty format for everything. So once you select that, you should be able to see all these DigiKey components. If you guys could let me know. Yeah, that should have done it. Okay, try this. Go to preferences in the footprint editor and click on manage footprint libraries. And then I have this right here, DigiKey footprints. That is there? Yeah. And you have it selected in here, the DigiKey dash footprints dot pretty. Oh, that's see, okay, so I don't have the DigiKey footprint here. If I go to manage footprint libraries, go to global libraries, I click on folder, DigiKey footprints dot pretty, DigiKey footprints. Okay. And then it shows up right here. Are you putting it in global or project? That is really weird. Hmm. I wonder if it's an issue how I have it set up because there were some weird changes. Like they changed a lot of stuff then when they went from KiCad 5.0 to 6.0. Well, no, it's up to date, but I had 5.0, so some things are a little weird as far as like where things are located. I wonder if my libraries and stuff is supposed, but if they're supposed to be elsewhere. But if they're in here in the global libraries, then you should be okay. Yeah, projects. Oh, okay. That's weird that it wouldn't show up in global though, either. Okay. All right. You should be able to see then now when you go to battery. So this isn't going to be a physical battery. Instead, it's going to be a connector for a what do they call them? Nickel batteries or the little they kind of look like little pills, the circular ones. we'll put in a device here that will allow you to snap in the battery terminal. We might have to change that at some point due to availability. So it all depends on what's available, but we'll get to that later. So now you should be able to go to the bulk edit, and then for BAT1, you'll be able to select this battery holder coin 2032 BS7. Isaac, were you able to download the library? Okay. Hey, I can probably go over it again. I just forget the exact website. DigiKey library. Yeah. Go ahead and, in fact, if you just type in uh, DigiKey library KiCad, it'll bring you to the thing. Let me know when you're on the GitHub website. Just click on code and then click on download zip. And so I'm not sure if you did this. It's up to preference how you want to save things. But I have a KiCad projects folder, and then I made a imported libraries folder, and then I named one DigiKey, and I saved it here, and that's where I unzipped it. So you can create. It was just for organization purposes. Depending whether you want to do this for a living or not, you're going to collect all these symbols, footprints, um, everything over time. You could even separate the symbols and footprints. Sometimes they come together, sometimes they don't. It all depends on where you download from. Okay. Um, for the rest of you, just for the meantime, just go ahead and go through all the components and start selecting the components if they haven't already been selected. Some of them are so like this Q1, this BAT1 are all DigiKey components, and the switch is from DigiKey. The rest of this are general components that you can find with the basic KiCad library. So just make sure you already have those connected. Um, this is important. So there is a difference. I'm not sure if you guys remember, but so there's surface mount technology or surface mount devices. It'll say SMT or SMD. And then there's also through hole technology or through hole devices. But I've most often seen THT. So depending on whether your components are surface mount or through hole will decide which one you want to use. And then there's also like basic connectors. So like if you have a different type of connector, they have various different types of connectors. That's a mixture of surface mount and through hole. Anything with these circular holes or through hole, the square and circle doesn't matter. The square is just so you know, oh, okay, it's for polarity purposes. So pin 1 is always the square part, or this is where the pins start. It can help you when actually creating the board. And then these are surface mount components. So these are a bunch of different pins, and something would go over this. So the component for this capacitor is a through hole. There's two types of components. So if you guys have seen like your basic resistor, right? It has leads on both ends. That type of component is called a axial component. So if you were to draw an axis through the resistor, it would go all the way through. So that's why it's called axial. The other type, which is more common for capacitors, is called radial, which is when the leads to the component are both on the same side. So in this case, I picked out a through hole capacitor. It's polarized because we're going to use electrolytic capacitors. It has a pin 1, pin 2, and then this is the positive side and this is the negative. For those of you that don't know, it is very important for electrolytic capacitors for you to pay attention to the polarity. If you don't have the polarity right, you're going to possibly blow your capacitors up and just make a large pop, and then it's no good. So I'm doing everything through hole because once we get the boards, we're going to put the components inside of them on ourselves. So once you've selected the capacitor through hole, there's tons and tons and tons of different types of capacitors. So here's all the axial capacitors I was talking about and all their different lengths, dimensions, and P is pitch, which is the distance between the pins from one center to the other center. You want, it's all the way down here, radial, 5 millimeter width, 2 millimeter pitch. That's the component you're going to pick. So you just double click that and then it should appear in here. The next one here for the 100 microfarad is a radial 6.3 millimeter diameter and 2.5 millimeter pitch. All the components here that we're picking are pretty generic. Most manufacturers will be able to make this, but sometimes your symbol could break the rules that you've set for your board. And so you will have to actually physically pick a different footprint for your component because the manufacturer, maybe if it has like a 0.5 millimeter pitch, right? Every pin is going to be extremely close to each other. And it's possible that the manufacturer can't do that. So if you send in that board, they're either going to deny you or it's not going to come out with as good quality because you didn't follow the rules of what the manufacturer said they could handle. And I'll go over a bit on how to configure that once we move on from this step. Did you get the footprints imported and everything? It should be. So you don't have to import them all one at a time. So if you go to preferences, go to manage symbol libraries, global. Okay, so here's all the different DigiKey libraries I imported, right? So I want you to click on add existing library to table. Got that? Yeah. Okay, then just go to the folder. It was DigiKey symbols. And then you'll see these sim files and lib files. If you click on this drop down, you can actually filter the other files out because you just want the lib files. And then if you select the first one and then scroll all the way down, hold shift and click I did it again. It should. Oh yeah, yeah, yeah. There you go. Select all of them. Yeah, that's true. Yeah. All right, so Control A, and I didn't notice the checkbox there, and that's kind of embarrassing. But that selects all the files for you, and then just click Open. I'm not going to click Open because I already have all of them imported. So just so you guys know, you can't have any of these with the same name. So I actually would have got a error, I believe, in saying, hey, all of these have the same name. You already have one imported. And then I have a few extras, but you just need the digit key ones. So once you've done that, just click OK, and it'll tell you if there's any errors or issues with what you imported. There should be none. Then the other thing is you need to go to here, edit footprints, or yeah. So this is where you would go to create footprints for specific components, or if you wanted to look at specific footprints for components, this is where you would view them. You need to now go to preferences and then manage footprint libraries. Again, I'm going to put mine in global. So then you're going to click on the file here, and you're going to click on, in this case for footprints, it's really weird. They just need the folder. They don't actually need like specific files. So if you just click digikey footprints.pretty, select that folder. I already have it, so I don't need a second one, but it should add it at the bottom. And then just click OK. Now, on the left column here, you should see appear digikey footprints. Yep, okay. So then you can close that now. And now you need to select all the footprints for each of these components. So I have them already selected, so if you guys can just go through. I'm not sure if you missed, but just so you guys know, axial is you know like what a resistor looks like, right? The leads go directly through the resistor. Not all the way through. They end at the connection part to the resistor, but since you can draw like a straight line through the axis of the resistor, they're called axial components. Whereas with capacitors, if you've seen electrolytic capacitors, they're cylindrical and they have the pins on the same side. They refer to those as radial. There. So keep that in mind while you're picking your components. You're going to learn a lot about the naming scheme of electrical components over time. There's a lot, but there's also like a general idea of like how you should name your components. So it's common practice to put like the diameter of the through holes, the pitch, which is the distance between your through holes. Here's another diameter, pitch, diameter, length. And so those are just useful so that you understand without having to look at the footprint, like what are the dimensions of this component? Because these are going to be the actual components we're going to put on the circuit board. So let me know, guys, when you have all the components picked out. Yes, they're all the exact same. So it's axial DIN 0207. 0207, that is actually a numbering scheme for telling your resistance values too, I believe. Yep, it looks like an Excel sheet. Mhm. So yeah. So in the footprint column here, you see that? Right, yeah. So they're all blank for you. So if you click in the footprint, like in the box, you should see a little library book pop up on the right. You see that? Oh, okay. Click. Oh, you didn't? Don't have the schematic. Yeah, so you have to place all the components. So the first video will walk you through all that. Another thing you'll have to do is after you placed all your components, you'll have to click on this button right here, and it associates all the components with a number and a letter. So like, for example, this is a switch, so it's S1. This is a resistor, so it's R1, R2, R3, R6, R7. It doesn't matter the order, it's just so that KiCad knows what component is related to what when you start making the PCB. Here's all the footprints again. So Q1 is actually going to be specifically a DigiKey component. So that will be in DigiKey footprints. If you scroll all the way down, it's TO-92-3. That's the transistor we're going to use. Q is for transistors as well. There's a standard for the naming scheme for all the components on a circuit board. I can find that website link. I'm not going to try and find it now, but there's a whole list of from A through Z, all the different types of components. You can also give them their own names too, like the battery is BAT1 instead. Which this helps to the viewer because they'll actually see that name on the board. All right, sounds good. Sounds good. Thanks, Zach. So then switch one here is also a DigiKey specific component. So that is going to be a switch slide. So it's just going to be like a physical switch. You can slide on and off. That's going to allow you so that when we have the name tag, you'll be able to shut it off so we're not draining the battery through the LEDs. So that would suck. And then finally, here's the 555 timer. So I customly made this 555 timer, but if you go, you can actually find one. If you don't want to go through all the specific libraries, you can also just type in 555 timer. I believe, okay, so you have to click on the library and search. So that would be in not connect. Footprints 555. Here you go. AMC 755 PDIP. All right, did you get all the, okay? And then you're making the schematic? Yeah. Okay. All right, cool. So now that we have all the footprints and everything, we can actually move on to the section I wanted. So now you're gonna, if you click on KiCad, open up the main page again. I already have it created, but you're gonna click on PCB editor. So I already have one, so it should come up with a prompt to name it. So I named this one IEEE badge. IEEE badge. You got it? Okay. The first thing I always do is I'll click on page settings, and I started this a long time ago. So you could just click on the arrow, that'll put in the date, what revision is it, what is this? It's the IEEE badge layout, or you can call it whatever you want. And so I guess I'll go ahead and do that. So it was version 1.0, IEEE badge company. Yeah, that's fine. That's good enough. Okay. And then the first thing you want to do is you want to make sure you have the proper grid that you want to start off. So you can change this grid size. Say like if I wanted to get like a very precise placement for components, I can change how close or how far each of these dots are, and your pointer here will actually snap. It'll snap to each dot. So you see, like if I wanted to make a more precise connection, I can't do it because it won't let me place anything in between. So I would go to the grid and I'd make it a little bit smaller, and now I can place right in the middle. If that's not small enough, we can go even smaller, and now it's almost like smooth again. So you can zoom in and zoom out however much you want to make sure you get an exact placement of your components. Just for the basic placement, I'm going to stick to 50 mils, which is 1.27 millimeters. Um, it's kind of crazy while you're making your design. It seems like your board is so big, and then you actually make it and it's like smaller than your hand. Like it feels kind of weird. It's something you gotta get used to. But the first thing you're actually going to want to do before we move all those footprints in is you're going to want to click on this page, edit board setup layers. And I just want to show you guys that um, it shows you here all your physical layers. So these are all the actual layers of paste, mask, silk screen, copper, the dielectric material. This is everything that's going to be on our board. You can change like your copper finish and connectors and whatnot. But the main thing I want you to look at is right here in design rules. So you can go to constraints and we can create specific clearances or distances. Minimum annular width is the width of the gold or copper part that's right around the hole. So that's what that's referring to, how long that is. Then you also have minimum via diameter, copper to hole clearances. Some manufacturers specify that all your traces must be a certain distance from any vias or through holes. And so you can set all those pre-made distances ahead of time. And it's important that you do this because then when you go to actually create the connections for your board, the software won't let you get that close to a through hole component or a via. Hey everyone, go ahead, just grab a seat anywhere. There's also net classes. So you can assign these net classes to every certain connection in your board. By default, everything has a default net class, but I can change clearances, track widths, via sizes, and everything here. So for example, I could create a new net list called VDD. And maybe I know in the back of my head, oh, this is going to be like 24 volts. So it's going to need a much wider track because there's going to be a lot of current going through it. We aren't going to need that, but I just want to show that you can assign that to all your tracks. See you later, Isaac. So our board is really basic. So we don't have to worry about this. Maybe we'll come back to it later, depending on what manufacturer we decide to go through. But we'll see how it goes. So then the last thing I'm gonna throw at you guys is if you click on this update PCB with changes made right here, go ahead and click update PCB and then click close. And now you should have all your components that you selected. All the footprints should appear right here. So, and then you would place it just by clicking. And then I'll leave you guys here. Next week, we'll start to actually make the cutout of the circuit board and we'll rearrange our components and we'll make all our connections. Okay? All right. I'm sorry. When you click on up, oh, here. These are just filter settings. So like if you had errors or wait for, you mean like the background here? Yep. Here. Oh yeah, no. You don't need any of these checked. They're different settings. So like the way the components came in, I had to place them, but sometimes you have to make changes to your board and you've already laid out everything. So like you can check mark some of these options like this one, replace footprints with those specified in the schematic and relink footprints to schematic symbols. So maybe I just wanted to keep it exactly where I placed the component, but maybe I picked a new footprint for it. And so it'll just plop the footprint where it was placed before automatically rather than me having to place it again. Because, like I said, sometimes you need really exact placement, and if you don't want to try and place it exactly where it was again, then you can change these options, and then when you click update PCB, it'll put the component in exactly where you placed it before. So it's just a easier way. Yep, no worries. Yeah, so just go ahead, place it somewhere in the middle. And then I'll show you guys how to create the actual circuit board, and we'll be able to finally see a 3D model of what our board's gonna look like. Okay. And then I'll show you guys a little bit. We're gonna go into Gerber files and how to import and export. For those of you watching online, this is the end of the first session. I have decided that I'm gonna cut the material down a little bit. I think I talked about a little bit too much in the first video. So this is all that we're going to go over for the first session now. And I'm going to now go over the same material with the next session of people that have came. So you guys have a great day, and I'll see you guys next week.